All right, ladies and gentlemen, welcome back. Today we're going to be talking about cofunctions. So cofunctions are a trig topic that are super easy to learn. Really easy, concept here. So the idea here is that we have pairs of functions. So you'll remember that we have sine of x as a function, we have cosine of x as a trig function, and we have tangent of x as a trig function. Now I'm here to tell you that there are actually three other functions in trigonometry. Okay, so we have the inverse. So what I mean by that is if sine of x is opposite over the hypotenuse, it turns out that there's this function called cosecant, and that is hypotenuse over the opposite. For cosine of x, it has a normal adjacent over hypotenuse, and there's something called secant, which is hypotenuse over adjacent. And then tangent, which is normally opposite over adjacent, has something called cotangent, which is adjacent over the opposite. So there's really 6 trig functions. Now, we generally only work with the first 3 because if you have hypotenuse and opposite, why not just use it as sine, right? But cofunctions bring about this idea of being able to find an equivalent value, being able to solve for x, and it's a cool little idea that happens in trigonometry. So with cofunctions, we have 3 pairs of cofunctions. Okay, so the first pair is sine of x and cosine of x are a pair. The next pair is cosecant of x and secant of x is a pair. And our third pair is tangent of x and cotangent of x. And the way this works is we get some equations. So for example, we would say that the sine of x is equal to the cosine of 90 minus x. Okay, what does this mean? Well, for example, let's say that x was equal to 30. This would mean that sine of x is equal to sine of 30, right? We have an actual value there now. That would mean that sine of 30 is equal to the cosine of 90 minus 30, which would be 60. And so if we pull up our handy-dandy calculator, don't forget to always check to make sure you're in degree mode, okay? But if we pull up our calculator and we figure out what the sine of 30 is, we get 0.5. And then if we figure out what the cosine of 60 is, we get 0.5. So that works out pretty nicely. And that allows us to do a couple of things, right? So what happens here is, one, we're going to find out that it really didn't matter what order we had. We could have had the sine of 90 minus x is equal to the cosine of x. It doesn't matter which one is just the x and which one is 90 minus x. Or we could have had cosecant of x equals the secant of 90 minus x. So what happens here is it doesn't matter which pair you have, but basically the idea here is that the sum of the two angles must be 90 degrees. Okay, that's all it means. Okay, so sum of the two angles must be 90 degrees. Now, does anyone remember where we get this idea of two things summing to 90 degrees? Think about it for a minute. Okay, so if you thought about it, we talked at the beginning of the year, we talked in the middle of the year, but this idea about things being complementary. So when things are complementary, they sum to 90 degrees. And that's where the in cofunctions actually comes from this part of complementary. So let's see what a problem might look like. Now I'm going to tell you in advance, what's really nice about these problems that you're going to see is that the pairs are already developed for you, so you don't have to worry and say, like, are these cofunctions? I'm telling you they're cofunction examples. So cosecant of x plus 60 and the second pair that we have is secant of 6x plus 2. Now it looks a little bit different than that formula, but the important part to remember is they sum to 90 degrees. So because cosecant and secant are one of our pairs, right? It's pair number 2. What we're going to end up with is just they are cofunctions. So to solve this problem, right? This is DeltaMath number 1 on mine. On yours it'll be different. But to solve this problem, all I have to do is do x plus 60 plus 6x plus 2 is equal to 90. That's it. From here, I can combine like terms. So x and 6x is 7x. 60 and 2 is 62. And that's equal to 90. Let's go ahead and solve this. So minus 62. 7x equals, okay, if you need it, you make sure you have your calculator handy. 28. We divide by 7, and you get x equals 4. That's it. Now, the part that you have to be careful about here, specifically when you look at the DeltaMath questions you're being asked, is you're asked what are the two angles, meaning you're not being asked what x is equal to, so we're going to have to plug back in. So the first one we're going to be plugging back into is x plus 60. The second one is 6x plus 2. We're plugging this 4 in. So this is going to be 64. This is going to be 6 times 4, which is 24, plus 2. We're going to get 26. So 64 and 26. Okay, we got the green arrow. We're good to go. So we can see how those cofunctions work. And every question is going to be just like this. Sine and cosine, you would set 8x plus 21 plus negative 2x plus 51 equal to 90. Solve for x, and then just plug back into 8x plus 21 and negative 2x plus 51, and you'll be able to find angle 1 and angle 2. It's that simple, ladies and gentlemen. So I hope you like this video on cofunctions. There are 10 questions that I'm asking you to do on the DeltaMath assignment for this. It should go rather quick for you. I hope that you, find this as a nifty little, piece for sine and cosine. So that's it for now, and I'll see you on the next video.